A 1,500 kilogram car moving east at 17 meters per seconds collides with an 1,800 kilogram car moving south at 15 meters per second, and the two cars stick together. What is the velocity of the cars right after the collision, and how much kinetic energy was converted to another form during the collision? We know momentum equals mass times velocity, so the momentum of the first car is found by multiplying the mass of 1,500 kilograms by 17 meters per second, which gives us 25,500 joules, 0 degrees east. And to find the momentum of the second car, we multiply 1,800 kilograms times 15 meters per second, which gives us 27,000 joules at 270 degrees south. And we need, and so the sum of the momentum in the x direction is equal to 25,500 times cosine 0, which is 1, plus, cosine 0 is equal to 1, plus 27,000 times cosine 270, which is equal to 0, so we get a total of 25,500 joules. In the x direction and the y direction, we have 25,500 times sine of 0, which is equal to 0, plus 27,000 times sine 270, so we get a momentum of 27,000 joules. Next we find the final momentum, or we'll say the initial momentum is equal to the final momentum. Take the square the momentum 1 and add it to the momentum of 2 squared, and then take the square root of that, and you get 37,138.3 kilogram meters per second. And then to find the angle, we take arctan of the momentum in the y direction divided by momentum in the x direction, which gives us a angle of 46.6 degrees south of east. And then next, we can actually find out the final velocity. We do that by taking the final momentum and dividing it by mass. We take the final momentum that I just got, and then add the two masses of the cars together and divide the momentum by that, and we get a final velocity of 11.25, and that's 46.6 degrees south of east. And since the cars are stuck together, they're both going to be, going in that direction. So the next question was how much kinetic energy was converted to another form during the collision. So kinetic energy is equal to 1/2 mass times velocity squared. The initial kinetic energy is 1/2 1,500 kilograms times 17 meters per second squared, plus 1/2 1,800 kilograms times 15 meters per second squared. And the initial kinetic energy is 490,250 joules. And we do the same thing with the final kinetic energy, except we plug in the numbers that I found towards the end of the last question, and we get a final kinetic energy of 208,828.125 joules. So found out once I subtract the final from the initial, we find out that 210,422 joules was converted into another form.